Greetings and welcome, friends. Mr. Waddy here, and I don't know if you guys know this, but sometimes life gives us problems where there's a lot of different ways you could solve that problem. And other times, life gives us a problem that's such a big problem, it will never be solved. And that's a scary day when you encounter a problem like that. So we're going to talk about two weird situations today in algebra, special solutions of linear equations. And it says this: equations do not always have one solution. All right. Actually, later on in the course, we'll even look at equations with two solutions. But today we're going to look at one or everything or nothing. So an equation that is true for all values of the variable, right, like x could be anything, is called an identity, and it has infinitely many solutions. So the number that you pick is just as good as the number that I pick, as anyone else, as any of the infinitely many numbers that exist. So that's what we're going to look at when that can occur. And then we'll also have situations, an equation that is not true for any value of the variable has no solution. And that's just like so sad. It's like you did all your algebra right. You opened the car door for the person when you went on the date. You paid for their meal, and like you were super kind to them. You were thoughtful. You asked them about their life, and then they still just don't like you, and they break your heart. And you're like, I did everything right. I don't understand. And it's just like nothing you did was good enough. There's just no solution, and I don't get it. Let's just go into the algebra. All right, it's gonna be okay. All right, Valentine's is coming up too, by the way, guys. All right, solve each equation and identify the number of solutions. So let's solve. What should I do first here, friends? Yeah, let's do some distributing, some multiplication by 3 by todo de los personas estás aquí in the paréntesis. I don't know if that's how you'd say parentheses, but 3 times 5x is 15x. 3 times 2 is 6 equals 15x. Now, perfect. We know how to solve with variables on both sides. We just move the little guy to the big guy. Who's the little guy? True, but in terms of the x's. Oh, wait, none of them are little guys. So, like, these two soon-to-be roommates are like, no, you should move into my apartment because I've got more stuff. And they're like, no, I'm pretty sure I've got more stuff. You should move into my apartment. And they're all just like, no, bro, I'm not doing that. I'm not moving my stuff. You move your stuff. And, like, there's just, like, an impasse. And when we try to move one of them, let's see what happens. These cancel out. And I just get 6 equals, no, this one's even better. It'll save us a step. And these cancel out. And what's a number that I have when everything is nothing? What's a 0? And I'm left with 6 equals 0, which boy, that's not helpful. That's not even true. My variables disappeared, and now you're telling me 6 equals 0? Luke Skywalker would tell you, that's impossible, right? And he's correct. This problem has what we would describe as no solution. And you know that there's no solution when you solve and like your variables all disappeared and you end up with a false statement. So because this was false, that's what led me to this conclusion. All right, no solution. Yeah, and that means I could pick any number I wanted for x, and none of them will work. If you plug in 1 as a check, it's not going to work. 0, 72, pi, negative square root of 34, none of them are going to work. Nothing works. This problem is just like way too picky. And it's like, listen, problem, you're going to have to lower your standards just a little bit, or you're never going to be happy. And this problem's just never going to be happy. No solution. So here we go. Let's solve this one. Over here, what should I do first? Yeah, let's do some distributing before we move anything. So we've got negative 2 times 4y is negative 8y. Negative 2 times 1 is negative 2 equals. And wait a minute. Guys, this is like deja vu. I think I've written this before. Was there a glitch in the Matrix or something? This is weird. Well, let's move the little guy to the big guy. So between negative 8y and negative 8y, they're the same. All right, let's add 8y to both sides, I guess. And those cancel out, and those cancel out. And I'm going to get negative 2 equals negative 2. Well, thank you for the obvious algebra. That is true. That makes sense. I agree that negative 2 equals negative 2, but that's not what I was trying to solve for. I was trying to figure out what y is equal to. And it turns out this is a case in which I could call this problem an identity, where it has infinitely many solutions. Wow, that's a lot of solutions. That means every single number works. And the reason I concluded that is because when my variables disappeared, I was left with a true statement, right? Negative 2 was equal to negative 2. And that then leads me to the conclusion that everything works. Todo de los solutions. All right, let's yeah, just to practice our solving and our fractions. Yeah, ooh, and then I've got one word problem. Or should I jump right into the word problems? No, well, we got time. We'll do what? Yeah. All right. Solving the equations. All right. Now this just says solve. It's possible there's solutions. It's possible there's no solution. It's possible everything works. Who knows? Let's find out together. It's the same packet. So it'll be just back a couple pages from our homework last night. So 4 times 1 is 4. 4 times negative p is negative 4p. 4p. And negative 4p plus 4 is what that's equal to. And then when I try to solve by adding 4p to both sides, those 4p's all cancel out, and I get 4 equals 4. Is that true or false, friends? That's true, right? 4 is equal to 4, right? If I ask my 5-year-old and I hold up 4 fingers, I say, are 4 fingers the same as 4 fingers? And he might say, well, those are left-handed fingers and those are right-handed. But 4 equals 4 is true, because these just cancel each other out. And because that's true, how many solutions do you think this will have? Infinitely many solutions. Infinitely. You like that word? I like that word. You like a finite number of solutions? Yeah. So, let us take a look at 5. Actually, tell you what, friends? I'm gonna hold off on my internet friends for a minute. Let's have you guys try to distribute that for. Oh wait. This is gonna have fractions the whole way through. Yeah. All right, let's find out what happens. I'll do this. All right, let's distribute 5/6. Oh, that's my least favorite number. Oh, I can also, what can I do to simplify on this side? 5/6. Let's see, Adriana, what can I do on this side to simplify? Yeah, so 6m's minus, how many m's are here? Yeah, so 6m minus 1m is 5m equals 5/6 times 6m. Those 6's would cancel out, and I'd have 5m. And now 5/6 times negative 10, that's going to be some work. That's a doozy. I could put that over 1 if that helps. So let's see what this cancels out to. Now 10 and 6 can both be divided by what number? Yeah, what's a number that divides into both of them? 2. And 2 goes into 6 3 times, into 10 5 times. So I'm going to end up getting 5 times -5 is -25 over 3 times, and if I put this 1 down here, 3 times 1 is 3. So I get -25/3. Kind of ugly there, but that's fine. And to solve, I'd bring the m's together, -5m minus 5m. What do I have on the left side here? What happened here? How much is left? 0. There's nothing. And this one, now you guys might not know what -25/3 is equal to, but you probably know that it's not equal to 0. That is a false statement. So how many solutions does this have? No solution. I don't remember. Maybe. Oh, maybe. Might have been. Wow, you got a good memory. Right, so no solution. Ain't nothing gonna work for this problem, no matter how hard you try. All right, let's talk about tugboats. Example 4, last problem. And you've got a little bit of some word problems today, so track with me, friends. Let's do this. This one's a little tricky. To make it less scary, I do have a picture of a tugboat. Does that make it better? You're like, okay, there we go. All right. Actually, this doesn't explicitly say it's a tugboat. I'm sorry, I might have lied. That looks tugboat-ish to me, though. I did not. And now you live here. Wonderful, wonderful. So guys, everyone should be tracking with me here. Let's see how we can do. Now, when we wrote equations, we followed the model VESA, V for variable, E for equation, right? S for solve, and then we wrote an answer. We'll see where the answer fits at the end. But so define my variable, we did that based off of the question. How far does the boat travel upstream? Okay, right, Devin, you're writing this down? Yeah. How far does the boat travel upstream? So you could use your different highlighters as well if that's going to help you out. So that sounds like a distance to me. Does that sound like a distance to you guys? Right, we'd measure that in distance. So I'm gonna let D. Where's my mouse here? Let D equal the distance upstream. I did. Yeah, so you're good then. You should turn off your Chromebook there, what you're doing. And let's measure this distance. What should I measure this distance in? Miles, and the reason I'm doing that is because I see miles per hour up here. So we'll measure this in miles. That sounds good. Now, this problem's a little bit tricky, friends. You actually, I don't know if you guys knew this formula, but I see a time. That's time. I see a rate. I see a time here. Guys, let's get along, friends. And we're going to need to know the formula rate times time equals distance. All right? Rate, time, and distance. Do you guys know that from like science class or anything? Maybe other math classes, you've seen that before. That's something that we had to smuggle into this problem in our brains because they didn't tell me that anywhere in this problem. All right? Yeah, so you just kind of had to know rate times time equals distance. And let's see. So let's read the problem before we go any further. I guess I haven't done that yet. A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. I think I'm going to need to define some more variables here. Let me Let me give myself some space. Let's see, watch this. Ha ha ha, I just buried that. You don't even know that it's there anymore. So I've got a couple situations. All right, let's just define everything we can. So I've got upstream and downstream. All right. And for each of these situations, I'm going to have a rate, a time, and a distance. Okay? So rate, time, distance. Rate, time, distance. Okay? So the rate is how fast I was going. That's a little tricky. Let's figure out time first. Figure out time. Let's see, it took 2.8 hours, the return trip, and 4 hours upstream. So 4 hours upstream. My time upstream was 4 hours. And my time downstream was 2.8 hours. You guys agree? Yeah? How about my distance? Distance. I don't know my distance. I just called my distance D. Is the distance upstream going to be the same as the distance downstream? Right? Like, unless that stream like suddenly like changed significantly due to flooding, the distance they went up is the same as the distance they went down. So these are the same in this case, right? Those are equal to each other. And how about the rate? This is trickier. Now it says, let's see, the boat travels 3 miles per hour faster downstream due to the current. So let's define a new variable. Let's let x equal the speed of the boat measured in miles per hour. And so x is how fast it was going upstream. And downstream, it was traveling faster, right? 3 miles per hour faster. So it's going to be x plus 3. Right? So if it was traveling 15 miles per hour upstream, because it's going against the current, how fast would it be traveling downstream? Right, Devin, you with me? It looks like you're looking at your phone, but I'm sure you're just like staring at your knee for some reason. Yeah. Well, it's up front as well. It's a continuation of Fridays. It's 1.3. So x and x plus 3, right? So if you're traveling 15 miles an hour upstream, we're traveling 18 down, right? And so let's see if I can write an equation kind of trying to combine all of this information. So I'm going to have, for my equation, rate times time equals distance. So rate times time, so x times 4 is equal to distance. But these distances are equal over here, so I'm going to actually have these equal to each other because the distances are equal. And over here, rate times time. So the rate is x plus 3 times time, 2.8, is equal to distance. And since the distances are equal, then these two things must be equal. This problem's a tricky problem, by the way. Tricky. Okay? Because we've got a lot going on. Maybe I'll have to practice some more of these with you guys later. So let's solve. I could simplify everything first. Let's just write that as 4x equals, and let's distribute the 2.8. You can distribute backwards, by the way. Did you guys know that? Yeah. So I'd have 2.8x plus 3 times 2.8. 3 times 2.8 is 8.4. And now what do I do to solve? I got to get those x's together. So who should I move? Who's smaller? 2.8. It's positive, so let's move it by subtracting. Right, so the solving part you guys are going to be fine with. It's just getting to the point where you write an equation is tricky. That's okay. So 4 minus 2.8, what's that, like 1.2? Think so. You could grab a calculator for that, though. These cancel out. I get 1.2 equals 8.4. And now what do I do? How do I get rid of that 1.2? Yeah, it's being multiplied, so the inverse is a division. And I get x equals 4. Now, what did x mean for our problem? Those are... Oh, no, for us, our x was the speed in miles per hour upstream. So for my answer, the boat went 4 miles per hour upstream. And I don't think they asked it. Oh, guys, that's interesting. I'm not answering the right question. I've got to figure out how far they went. This was the speed. I've got to find the distance. A distance of... How could I find the distance? No. Rate times time equals distance. So the distance is equal to x times 4, or 4 times x. Oh man, that's tricky. I almost thought I was done, and then I was answering the wrong question, which we found it, but... So the distance is going to be 4 times 4, which is 16. And distance, Devin, is going to be measured in miles. So a distance of 16 miles. I guess I gave them more information than they bargained for, but that's all right. I'm fine with that. So I will end up having you guys practice some problems writing equations, because that's the hard part. Usually solving, you guys will be okay. Also, I want to point out I could have found the distance by plugging 4 in for... I could have done x plus 3 is 7, and 7 times 2.8 would have equaled 16 as well. So there's a few different ways I could get that. All right, well, thanks for watching. Mis amigos de internet. Bye.